problem that we started yesterday. I'm going to teach you one last technique, and then I'm going to learn you something. That's right. And then we'll go over more questions. Okay. So, could somebody tell me where we left off? You said I was halfway in between.
May, June 2006. I think we saw for K, but we didn't do the rest of it.
Got it.
I don't have K yet.
Case
You don't-
27.
I think it.
Okay. I'll talk about it.
She said we should get right now.
Looks like that. Y is x cubed. Give me the thing.
Y is x cubed minus 3x squared
Yep.
minus 9x
Yep.
plus K.
Got it. Okay, so. He's good. Okay, so what we're going to do today is we're going to talk a little bit about how do we go about this problem. I love because it kind of reviews everything we've done up until now. Bless you. So the way we start by looking at this, the first thing it says is that here's a minimum, right? And it also says that it hits the x-axis. So what do I know about that thing if I know it hits the x-axis?
Y is 0.
I know automatically that y is 0. So if I'm looking for an ordered pair, I've got at least that. Now, good reason why I like to do this problem midway through the year like this is because it reminds me of, first of all, how do I find minimums and maximums? So the technique of finding min and max is to take the derivative, to set it to 0 to solve for x. Okay, that actually finds minimum and maximum. Now, a lot of people like to say the second derivative test. Specifically what the second derivative test does for us is it tells me this is indeed a minimum, this is indeed a maximum. Okay, so it gives me what the minimum and maximums could be, and then the second derivative test tells me exactly what they are. So question, yes.
Which one are we on?
May,
May 2006.
May, June 2006.
Number 10.
Number 10. Okay, question, yes.
So the minimum or maximum, that's the same as a stationary point?
Absolutely, just another word for it.
And like that'd be the vertex. Like if it's a x squared, then
It'd be
vertex.
your bottom,
Yeah.
bottom of the barrel and top of the top, right? Okay, so how do we go about doing it? Well, we take the first derivative. We find y prime. So y prime in this case is 3x squared minus 6x minus 9. K is a constant, so therefore its derivative is 0. It's going away, okay? So now I have this trinomial, and I have to, by the rules of trying to find a max and min, set this to 0. Well, I like it when they give the trinomial because we can understand how to start to solve for 0. One thing I do recognize is that it has multiples of 3 all the way through, so does it make sense that I can divide by 3 all the way through?
Yes.
So if I divide everything by 3, I get x squared minus 2x minus 3 is 0. As long as it's equal to 0, I'm allowed to divide both sides by it. Okay, now, this is something I could factor. It screams I'm a trinomial. Factor me, right?
Yeah.
So we're going to factor it in this way. We got x, we got x, we got 3, we got 1, we got negative, positive. X is 3, x is negative 1. Now we have to be smarter than the problem. I got 2 potential max and mins, yes.
Did we already start this?
We did, but I was just kind of reviewing it. Yeah, we were about halfway through. We got 2 potential max and mins, right? Is it obvious which one goes with which one? Like this is x equals 3, this is x equals negative 1. Would you agree with me if I looked at this picture, negative 1 has to happen here, while 3 has to happen here? Is everybody okay with that? 3 is positive in the first quadrant, negative 1 would be back here, right? So I know that this right here, this ordered pair, it's going to be 3, 0. Why do I know it's going to be 3, 0? Because it told me it hits the x-axis. Everybody good? Yes.
So in this case, we're only caring about the minimum?
For now. Because actually the problem actually says find the minimum, I think.
It says the maximum. For part II,
Part
find the
II,
coordinates.
Well, to find...
Which one is find the value of K?
Well, we use one that we actually have an x and a y to find k.
Because the other one, we don't really know. We just have negative 1, but we don't know what y is.
Correct.
Yeah.
Right. And once we know k, we're good to go. Yeah. So yes.
But if you had a value for y, you could use either one.
Yes,
Right.
of course. Yeah, you got it. The only reason why we knew the value for this one is because it told me it hits the x-axis.
Right.
Okay, so now I'm going to take 0 is 3 to the third minus 3 times 3 to the second minus 9 times 3 plus k.
Yep.
Lots of 3 stuff going on.
27 minus 27 minus 27 plus k.
27 minus 27 minus 27 plus k. Cool.
K equals 27.
Yeah, because these 27s cancel each other out. If I add the 27 overs.
We set it equal to 12 instead of 0.
Oh, did you?
Yeah. We set y equal to 12.
Okay. Do you see that y you should have?
Yeah.
Okay.
Why'd you say we don't know.
We just did that.
They don't
So, because we got y.
Okay.
Because it was a
We
number.
felt like
6x minus 6.
12 is there.
We took the second derivative.
Oh, they did say, well, you know, they kind of went down a path of second derivative.
Yeah.
But the only thing second derivative would do for me is say,
Right.
oh, yes, indeed, this is definitely the
And that's-
minimum.
Yeah.
And that's probably what y'all did. Okay, so now I know for certain that k is 27.
Uh-huh.
Now that I know k is 27, I actually have a full complete y equals equation, right?
Yep.
And so I also know that this was 3, 0. I
Uh-huh.
also know that this is -1 something, right?
Yeah.
For me to be able to find that something, I could just plug it in to x, now that I know k, and I can find that something. Kalia, you good?
Oh.
Okay,
Can you repeat what you did?
I sure can. So are you cool with how we found k to be 27? So we just plugged 27 here. So you recognize now that we have an x, an x, an x, and we don't have an unknown now, we have a 27. So if I know what x is, does it make sense if I plug it in, I could find what the y value is? So part II says now, tell us the ordered pair for the maximum. Okay, so it's going to be y is equal to -1 to the third minus 3 times -1 squared minus 9 times -1 plus 27.
Uh-huh.
Everybody good? So it's -1 minus 3 plus 9 plus 27 is y. Everybody
32.
got that. So y is 32. So the ordered pair for part II of the maximum is -132. Yes.
But isn't it like they're not like absolute maximums or minimums because that keeps going and that also keeps going. So like they're relatives. Right?
Very good. Absolutely right.
But in this case, I mean that really doesn't matter. It's just that where we see it's the highest point and
It's
where
our
the lowest
highest point on our picture,
Yeah.
right? Okay, so now what does the next part say?
Set the values of x.
For which it's decreasing, right? For
Yes.
which it's going downhill. This one is really supposed to be a very easy problem. You're supposed to recognize that it goes up, 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 up till it hits your max, right?
Uh-huh.
And then from that max, it starts to go down until it hits a min,
Uh-huh.
and then it starts to go up again. So from blue line to blue line is where this thing is going to be decreasing. Okay?
Right.
So does it include the blue line? No. Because those are actually my max and my min. That's the top of the roller coaster. Then I start to go down, right?
Is it from 0 to 2?
So it's actually my x values is what we talk about, not y's. So you're going to say from -1 to 3.
3.
But why don't I thought you didn't count them. Oh, because.
So we're talking, because what does the question actually read?
State the set of values of x for which x cubed minus 3x squared minus 9x plus k is a decreasing function of
Okay.
x.
Would you do less than, or would you do less than or equal to?
Well, why not equal to?
Because you can.
Because remember, this is the top of the roller coaster.
Oh,
That's where it
right.
stops, right? And then it
Right.
starts to go down. And so it asks for the x values specifically.
Hmm.
What if the question was a little different and said, state the x values of which it was increasing? So do you agree you would go from -infinity, right,
Yeah.
to -1, and then our other option would have been from 3 to infinity. And it's basically the union of the two. It's those two on the outskirts. Yes.
Can you do like the chart thing for that? So how would that work with the chart? Remember like when we did the chart and then we plugged in values?
Yeah, but that would be, you would make more work for yourself. What you would do is you would set up the chart, you would use the first derivative, you would plug a value in that falls in that category in that first derivative, and you would show whether it's positive or negative.
Uh-huh.
How many points is this one worth?
One.
One. So they're not expecting you to do that. Okay? They're not expecting you to go through that process. They're expecting you to recognize this thing is decreasing from here to here. They are also looking to see, do you understand that those high and low points should not be included? So if you had the equal to and equal to, they'd mark it wrong. Does that make sense? Okay. Now, what's the last part asked me to do? Shaded region, I assume, is here to here? Okay. So, yeah. So from the 0, the shaded region would probably go from here all the way to here, right? Okay, so remember, person standing, right?
Yeah.
So person standing, we're going to go from ceiling to floor, wall to wall. So the ceiling, okay, so let's talk wall to wall. What's my leftmost wall for that guy's house?
0.
0.
Zero.
You guys would agree? It tells me that's where it stops. Things that people might make mistakes on is knowing that we've done this whole problem. We got -1 as one of our answers. We'll stick in -1 by mistake. But recognize where that shading happens, okay? It's just a simple mistake. So from here, the leftmost is 0. What's the rightmost? It is 3.
3.
Everybody good? Now, where does the guy's head touch? It actually touches the curve, right?
Yeah.
What do we call the curve? Well, we call the curve x cubed minus 3x squared minus 9x plus 27. Yes. Well, let's talk about the floor. So what's...
Okay. 3 and 0.
How do we get that? Well, remember it's from wall to wall and then ceiling to floor. So what's my leftmost place on your shading? The leftmost place is this line right here. Okay? It's known as the y-axis, but it's also known as x equals 0. And then what's my rightmost? My picture's not very pretty. My rightmost is all the way to the 3. If you look at your picture, it should. Yes, Jake?
I just, did you use the maximum point of the curve?
The maximum point is over here,
Right.
and we knew -1 was one of them when we factored.
Yeah.
So when we plugged -1 in, we got 132. Yeah. Okay. You had a question?
I was just saying, so when you're taking the area, you only care about your x values.
Only x's.
Yes.
So you're going to go there to there, and then here to here. Well, the here on the bottom is a floor. Our floor is 0. So 90% of the time, the floor is going to be 0. If I subtract 0, does it really matter in the scheme of things? No. But just keep in your mind that that floor might be it could be something different.
Could be
Okay?
1.
It could be 1.
Well, if it was just, if you knew it was 1, would you just subtract 1 from
Minus
there?
1.
Okay, and if it was like y equals x, then it would be minus x. Right?
Yeah. Okay, so now we're just going to put the little dx and say, yay, we can take an integral, and you're going to integrate. This should be a pretty easy integral. They're big exponential powers, but it should be a pretty easy integral. So remember, we add 1 whole to each part. And do we need a c? No,
No, because we have an A
and
in
a b, right? Yes.
So whenever we do problems like this, do we take the integral of the thing that's not the derivative, the function?
Correct.
Like we wouldn't take the derivative and then take that and do the integral.
No, you want to do it of the original function.
Right.
Because truly,
Because
what
if
is...
you took the derivative and you did it again and just go back to
Right,
it.
to it, yeah. So
Yes.
truly what you're looking at is where is the top of this shaded region? Well, it's the actual equation, not the derivative of it. Okay, so did everybody get that right? Integration-wise? Okay, so we're going to plug in, and you guys hopefully agree that 3 divided by 3 is just 1, so I'm just going to put x cubed. Makes it a little bit more cleaner, I guess. So plug in your 3. So you would have 3 to the 4th over 4, minus 3 to the 3rd, minus 9 times 3 to the 2nd over 2, plus 27 times 3. Now, you're also going to plug in the 0, the bottom.
It'll just be.
It washes itself out. So just pay attention, make sure. So like if you plug in a 0, a 0, a 0, a 0, I don't have to worry about it. Okay, so minus 0 basically. So you can do the calculations of this, hopefully. 81/4 minus 27 minus 81/2 plus 9 times 27, 81. Is that right? Yeah. And hopefully you guys can do the math for me. Weird fractions. I think if they don't say
I got 135.
Yeah, 135 over 4.
135 over 4, cool. If you get a decimal, it's okay. 3 decimals out. Yeah.
Well, the mark scheme had it as 33.75.
Yeah,
So
There we go. There we go.
They're kind of
Which is
weird.
nice.
Like they sometimes like fractions.
Sometimes they don't,
they
and I don't think they would mark you wrong. If you came up with 135/4, they'd be like, cool, he's got it.
Uh-huh.
You know, so. Depends on what the directions on the front
What
say.
is it?
135/4, also known as 33.75. There we go. Okay, are we good?
Yes.
Nice. I like that problem because it does a great bit of a review on stuff. Okay, now another thing I want to talk about. So I'm gonna throw a wrench in the game here. You guys have been comfortably hanging here and doing these problems, and I feel like everybody kind of likes them in a little way. I'm going to show you something called U-Substitution.
Okay, I'm not gonna learn that.
Well, remember when I told you, I explained chain rule to you,
Yep.
right? So what was the purpose of the chain rule? It was to take the derivative of the inside as well, right? Not to leave that stuff alone. The U-substitution kind of reverses that, yeah.
Wasn't that like where you had something that was in parentheses raised to a power? And then
Exactly.
you did like the whole thing and then you did the individual parts?
You have to trinomial it, basically. You have to boil it out.
Right, if you could, sometimes it's square root, right? So sometimes you just can't do that. Okay, so U-substitution. Once in a great while, it'll come up on an AICE exam. Bless you. So that's something we want to kind of pay attention to, hopefully have an understanding of. So U-substitution is a little bit different. If I'm doing a problem, and let me give you an example of one. Let's say we're going to do just a simplistic one for now. Okay, so here we go. So if I'm looking at this thing right now, currently, how would we actually integrate that? How would we, with our knowledge base? We would FOIL it out, right? And then we would do the integral of each of the individual pieces. Bless you. And then we'd have a plus c at the end because it's a, yeah. Okay. So it makes sense that we could FOIL it out. But the example I gave just a second ago is what if it was a square root? I couldn't FOIL it out, right? There would be no way that could happen. So I'm going to show you this thing called U-substitution that allows you to take an integral of something like the square root of something like this, where it's not, it makes it a lot easier to work with. So the first thing you have to do is recognize that there's something on the inside. Okay, the something on the inside, does it sound familiar? Because with chain rule we had to recognize it was something on the inside and then something on the outside. What is the something on the inside in this particular problem?
2x plus 1.
Okay, so we're going to call U to be the stuff on the inside. 2x plus 1. So far so good? And it's scary anyone yet? Now, we're actually going to, yes.
Is always the stuff on the inside?
Always the stuff on the inside, yeah. Now we're going to derive, what do I mean by derive? Take a derivative of the stuff on the inside. How we call it is du. Okay? So I want to take the derivative of the u. So what is the derivative of our u in this case? So
2.
What's 2? Now tell me you took its derivative. So it's going to be 2 dx.
Wait, what?
Okay? So what you did was, okay, so Jake, are you cool with what the u is?
Yeah.
Okay, are you cool with the derivative of this being 2? And what you're going to do, just one last step, is you're going to say dx attached.
With respect to x.
Because think about it this way, if I divide it by dx, what do I have here? I have du dx is 2. Derivative of u with respect to x is 2, which is basically what happens. This, in this form, is what we call a differential, meaning I have the du and the dx on the other side. So that's just kind of the name for it, the math name for it. Now, so everybody cool with what I just did? I took the u, I found out what u was, I took its derivative. Everybody comfortable? Okay. So what we need to do now is take this original problem and we are going to rewrite it in terms of u, hence the name U-substitution. We're going to rewrite it with u's only, no more x's. So I still have an integral symbol, and instead of 2x plus 1 squared, what would I write? I would write u squared. Would you agree?
Yeah.
What was 2x plus 1?
Okay.
You just
It's u.
plug
I
that
just
in.
plugged it
yeah.
in, right? Okay. Now, I need the du attached. I can't have a dx. I need a du attached. So here's the dilemma. I want du written here. How close am I in this original problem to having the du that I need? I'm close, right? I'm half there, right? Does that make sense? I need a 2 in there. So here's what I'm going to do to this original problem. I'm going to stick a 2 in there. Did I change its value? If I stick a 2 in there, I change its value a lot, right? I double it. So what is the one thing in this world that if I put a 2 in there that would say, but I could put something else in there that it wouldn't change it? So, close. 0.5, also known as 1/2, right? So how did you come up with the number 1/2? You used the reciprocal of this, right? So I stuck a 2 in there to make it look like that. So rather than just sticking a 2 in there, I'm going to put a 1/2 out front.
I don't understand it.
Okay, what is 1/2 times 2? 1 whole, which is exactly where we started.
Oh, I see.
I
Okay?
got lost when you brought down the u squared.
Okay, so do you agree that this is 2x plus 1? Do you agree that this is also called u?
Sure.
So instead of 2x plus 1, I replaced it with a u. It's called U-Substitution.
Okay.
Okay, so let me repeat like what I've done so far. So the first thing is I had a problem and I recognized that it's something contained. So I took it and rewrote it in terms of u, and I took its derivative right next to it. I am so close to having the perfect everything in terms of u. Real close. So if I look at this, this is u squared, right? And then dx, I'm so close to having the whole thing. I need a 2 to make it du. So I stick a 2 in there, which is a big no-no. You can't change it like that. So for me to fix that, I pull its reciprocal out front. Okay? So now I'm going to just bring that 1/2 down. And let's talk about why I did all that, and let's see if it correlates to the original. Okay, so do you guys see where the u squared came from?
Yeah.
So far it makes sense, right? Do you see where the du comes from? Well, du is just 2x. I have a 2x now that I stuck a 2 in there. I can't really just stick a 2 in there. I have to change it by its reciprocal. Okay? So this comes down for the ride. This is now u squared. This is now du. Do you see any more x's in it? They're gone, right? So the x's are completely gone. Now, would you know how to take an integral of something that looks like u squared?
Yes.
What is it?
U to the third over 3.
Right? Okay. Make the 1/2 go for the ride.
Yeah.
That was out front, the green thing. Remember when I take an integral of it, that du part goes away. We've been doing it all the time with the dx. It goes away. We don't even care about it anymore. What's the only thing I'm missing on the outside here? I'm missing a plus c. Because
Why do
it's,
we have to do it for
say it again.
Why do we have to put a C for?
Because we don't.
I don't have an a and a b,
Oh.
so I need a c. Now, the only last problem is, I started in terms of x. I used U-Substitution. And I now have to go back to x. That's the only thing that changes this problem. So what would I do to go back to x? Well, what is u? It's 2x plus 1.
Uh-huh.
So the end result is 2x plus 1 to the third, right? And what's 1/2 times 3? Those 2 and the 3 make a 6. Plus c, done.
Do
Yes.
you have to keep the 1/2?
You multiply it by the.
I multiplied by the 3, right? I made
Oh, you
these
did
two
it.
guys. Yeah, I made it become 6. Yes, Jake?
Can we just do it the normal way?
For this, absolutely, but not for a square root, so I'll show you one of those.
Okay.
Okay?
Right.
Or even a cube root. Yes.
So you say like they don't always do this?
It shows up occasionally.
Let's hope it doesn't.
No, you'll be fine. Once you do a few of them, you'll be fine. You'll get the feel for it.
It just seems kind of weird.
Do you solve for
It's very
C
strange.
or
You don't have to solve, well, a lot of times no.
They give you a value.
Sometimes. Okay, so let me show you one that Jake won't be able to do the regular way.
So that's the answer?
That's it. Done. Yeah.
So if that wasn't squared at the beginning, it was like to the cube, right?
Yeah.
So you put 1/3 on the outside?
Well, let's Depends, let's do that. Tell me what you want, make up a problem for me.
5x plus 2
To the third?
Yeah.
Let's do one that you can't expand. To the 1/8?
Of course.
To the 1/8?
Why not?
You put 8 on the outside.
No. We're cool. Okay, so does everybody see what we got so far? Do you agree with me, Jake, that I can't do anything with the 1/8? This is a done deal.
You can.
I can't expand it.
No.
I'd like to, but I can't, right? So, I must use U-Substitution. Step 1, name your U.
5x.
The U is
5x plus 2.
plus 2.
That's what I meant.
Cool? So DU is, you guys agree, 5
dx with respect to
And
x.
then you have to put 5 in that and 1/5 on the answer.
Right.
So now I'm going to rewrite this whole thing in terms of U.
Okay.
Yeah? You seeing it? Now you know your answer.
I'm relating the exponent to the outside.
Right, that's exactly right. And I see where you're at, but that's why I wanted to show you. So I'm going to rewrite this whole thing. What? It's on top. U to the 1/8. I think everybody's cool with that, right? And I'm so close to having du. The problem is I need a 5. So what do? I insert the 5
You know, 1/5.
and pull out the 1/5.
Okay. And then what do you do?
Okay, so now 5 dx is the du I was looking for.
Yeah.
Okay, and that 1/5 just comes down for the ride. Now I integrate. So 1/5 goes for the ride. What's the integral of u to the 1/8? Will I add 8/8 to it? So
9.
u to the 9/8
Over 9/8.
over 9/8. Don't forget your c.
This one.
We'll clean her up a little bit because it has to go back to x's.
And then you plug in 5x plus 2 in for u.
So take this guy, flip her up. So 1/5 times 8/9, right? And then u is 5x plus 2
To the 8/9.
to the 1/8.
Or 9/8.
Or 9/8,
Yeah.
sorry, yep. And then plus c. And then you can do a little math magic with this thing here. Yes.
But they don't want you to find c.
No, yes and no. And we'll talk about how it works. Sometimes you won't need plus c because you'll have an a and a b.
Is that a 9 or a 5?
That's a good question. It's a 9. What do you think?
Do you get 8/45?
That's hard.
Yeah,
8/45. Good job. Yeah. It's really not bad.
So you have 8/45. 9/45. And then you can just leave the rest?
Yeah.
Yeah.
It's probably just going to
I'm
answer the
ignoring you.
equation.
Hmm? Yeah.
So you just basically, when you have like the chain rule type setup, you take integral of the whole thing times the reciprocal of the integral of the inside. So that's all it is.
That's all it is.
Alright.
That's all it is. That's all. How about this, guys?
I think.
This might be one you would see.
Sorry.
How would I integrate that? Yeah.
It would be 1 times x plus 3 to the negative 1/2.
That's exactly right. This is exactly one that you might see on an AICE exam.
Hold on.
So what did he recognize? He recognized that he doesn't know how to take an integral of something in a denominator.
Right.
So he's going to flip it up
To
to
the
x
1/2.
plus 3 to the negative 1/2. Because it's in the bottom, so when you flip it up, it goes to the negative 1/2.
And it's a square root, so it's 1/2. If it was the cube root, it would be negative 1/3.
Right. So now let's use U-substitution for it, okay? So I'm going to integrate x plus 3 to the negative 1/2. What's u? Oh, what did I forget? Dx.
Dx.
What is u?
X plus 3.
X plus 3. What's du? Ooh, 1 dx. That's
1.
kind of nice.
Yeah.
Dude, the reciprocal, that's just
I don't need to stick anything in because I got what I need.
Wait, what? Can you say that one more time?
Yeah,
Du is what?
dx.
Just dx.
Because the derivative of 1 is,
1.
yeah. If I had a 3 here,
Okay.
then I would need
Oh,
a
I
3
see.
here.
Okay.
Then I would need a 3 here, which
And
means
then
I would need a 1/3 here.
But you don't need it.
But I don't need it. So, okay, so rewriting this problem in terms of u is going to be u to the negative 1/2 du.
We already have to use.
What's the integral of u to the negative 1/2? You add 1 whole to it, right? So what would that be? U to the 1/2 over 1/2, right? Plus C.
And you would just do the square root of u over 1/2.
Or just flip the 1/2 to be a what? A 2?
2.
So flip that guy up, you got 2, and that
X
U,
plus 3 to the 1/2.
yeah, x plus 3 to the 1/2.
And then if you do the chain rule, it gets back to the other thing, so that's a minute check.
It does go back to the original. Because if I did the chain rule, I'd have 1 times that,
So you don't want
and
us
then
to
that
just
to the
repeat
negative
two?
1/2. No,
Do you not want us to write it as 2 to the square root of x?
either way. And like you said, you can check your work. Look, 1/2 times this is 1. Rewrite the inside, subtract 1 whole. What do you get? Negative 1/2.
And then times
So
the derivative of the inside, which is 1.
just 1.
So,
So what do you think? It's not hard. Are you taking the next level next year?
Yeah.
Oh boy.
Everyone says it's easier.
I feel like it's not. I feel like
They're
just used to
It's
it.
expanding on this.
You know what I mean?
I feel like it's gonna take someone to pretend to be me.
Okay, yeah, that'll work. So dy over dx is equal to 4 over the square root of 6 minus 2x. Passes through the point 1/8. Find the equation of the curve.
So, got a question. So, when we do that, right? We don't have to put plus C because we're gonna have.
Well,
or no?
it's passing through the
No.
point, right?
It'll say
Passes through the point.
where x is 1 and x
Yeah.
is 8. When it gives us 2 x's, we use a plus
Right.
b, but it only gives us 1.
You see the difference? If it said from x is 1 and x is 10, then you know you have an a and a b. But this one says it passes through the point, which is an x and a y.
All right, I'll do that for lunch.
Because when we find the,
What the heck?
when we get that,
Is that just bread?
No, it's peanut jelly.
No, it's.
It's
I for real just thought he had like 10 slices of bread.
Miss Carrie, you're doing that.
Did he just say like
Aye. This was May, June 2006. I guess it's something. May, June. You feel bad for my food bill?
Yeah, I wonder what your
Yeah.
grocery bill is.
when you said yesterday about, she drew the person that arms were coming like out of her legs, and she's like, that's how it is in my family. I didn't even know Miss Larson was here, and she just started cracking up and
Miss
it
Larson
scared me
was here?
so. I was like, there's never anyone ever
She was
behind
getting a whole
me.
period.
Oh no.
Well, she kind of left towards the end.
How many
Towards the
times
end.
do you go grocery shopping just like one time a week, or do you like go twice a week?
The real question is,
every
do
day.
you
I
go to
thought you go
Sam's
every morning
Club?
at like 4
You go
o'clock.
every day. You're
Do you go to Sam's Club or Walmart?
Do a little of everything. Depends on the sunscreen.
She really
You
does
know-
like every day because like every time I'm home, like there's groceries and like every time I'm over, they come home with groceries. It's so funny.
Like Walmart at 5 a.m. on Saturday.
Is it like 4
Yeah.
That's
It's
awesome.
shy of about like 1,000, 2,000.
Ooh,
That's
you're just like,
I know. I was
That grocery bill was worth it.
every penny. Okay, so do you see what's happening here? Now I'm looking at it and I rewrote it. I pulled that guy up, right? Everybody good? Okay. It does the same thing for me. The only thing that I was afraid that you guys might not understand here is that 4 is in the numerator, so it must stay in the numerator. See how it is? It's 4, and then I flip that guy up next to it. Is everybody good?
yes.
And really that 4 can come out here and just go for the ride.
So you don't have to distribute it?
You don't have to do you won't do anything to it until the very end. Yes.
So, but how did you know to move the dx over?
Well, because everything we've done up until now, we've had something dx, right?
Yeah.
So it's easier for U-Substitution to understand the dx is over there with it.
Uh-huh.
Okay. So what is the integral dy? It's y. Okay? So this over here is easy enough. We're done.
Yeah.
Okay? Now over here, okay, so we're going to use U-Substitution. How do I know I have to use it? Because this is to the negative 1/2 and I can't expand that. So what is u?
6 minus 2x.
6 minus 2x. What is du? Negative
Negative 2
dx, right?
dx.
Kalia, tell me what I need to do.
Okay, so now, hold on, let me go back to my notes.
That's okay. Remember the 4 we're just ignoring for a moment,
You have to add. Ooh,
okay?
got it.
I have, do you agree at this point I have I have the number, I'll write it down here. I have the number 4, right? Which
Yeah.
doesn't matter in the scheme of things for now. I have u to the negative 1/2, would you agree?
Yeah.
And how close am I to having du? I'm real close.
Yeah.
But what's the problem with it?
You put a -2, but then you have 1/2 or negative 1/2.
Negative 1/2. Cool. And then du. Now, do you notice that 4, I just kind of brought it with it? Truly, I can bring the 4 out front if I wanted to. I could just put the 4 here and have -2 out front if I want to. It does the same job. So over here, my integral's done. I've got u. I've got -2. What's the integral of u to the negative 1/2? Well, it's u to the 1/2 over 1/2. Would you agree?
Yes.
Okay, so u to the 1/2
Over 1/2.
plus c. Now I'm really close to being where I need to be.
You flip it up and just have negative.
I need to flip it up, okay? So when I flip it up, what do I have? I got y equals -4, right? And I don't want u. What do I want?
You want 6 minus 2x.
I do. I want 6 minus 2x. So 6 minus 2x to the 1/2 plus c. Yes.
But how did you know to get rid of? You got rid of the du. Why'd you do that?
Well, remember when I take an integral of the
Right.
derivative, it brings me back to the original, and the original doesn't have a du in it. Does that make sense?
But did you need to do it there because you had?
Say it again.
Did you need to put it there because like you had dy became y, so then shouldn't dx and du just go away?
Well, it became because right now it's 1. So the
Uh-huh.
integral of 1 is y. Truly what's happening is we're integrating this. And so it's 1 dy, the dy disappears.
Uh-huh.
It's all this stuff dx, and we take an integral and the dx, they disappear. Did that make sense? That's kind of the concept of it. Because when I integrate the derivative, I go back to the original, and the
So
original will not have a
Do you
dx. or
plug
du.
in the 1 and the 8?
Correct. Now I plug in the 1 and I plug in the 8 and I solve for c, and I would have the equation of the original. Yes.
Now, if you forgot, like, that 1/2 can be flipped up and made a 4, if you left it 1/2, would it mark it wrong? That was just,
But you're going to eventually take care of that when you plug.
But
Like
if you
when
didn't
you
have to plug
plug
it
in the
back
1 and 8, you'll work it.
but even if you didn't, like, have to plug it in, like, that was your final answer.
That'd be
like,
fine.
It'd be fine, okay.
Yeah. So I'm going to plug in. I got 8 equals -4, and then 6 minus 2 times 1 to the 1/2 plus c. Everybody good? I plugged in the 1 for x, the 8 for y. So what's happening here? I've got, you guys agree 4 to the 1/2, which is 2, right? So I got 8 equals -4 times 2 plus c. Everybody good?
So 16 equals C?
0?
Yeah.
Well, it's 16, right? Yeah, good job. So c is 16. So right here, instead of the c, I put plus 16.
And then you're done.
Then I'm done. And that was number, I think I put it up there, May, June 2006, part II. Yeah,
That's kind of weird. They didn't even mention U-Substitution,
No,
but
they
they
won't.
wanted you to do that.
they won't.
So how do you know? Like, what's like key words to
Well,
look
what's,
at?
what's key to me is when I look at that
When you look
thing
at that,
and I
you
see a
can't-
square root, I'm thinking, I can't expand the square root.
But and then it says the normal to the curve.
Well,
We
that's, yeah, that's another story. That's,
Oh, we just did part II.
yes, we did.
Okay.
Let me see if I can find another one.
I think this one out.
Okay,
Did you remember for October, November 2000?
2000 what?
October 2002, 4?
Oh, we did the first one.
I think
That's
easier
right.
one.
That is a good one. Okay, that's a good one. Bottom of the page, October, November 2002. The gradient at any point x, y on the curve is square root of 1 plus 2x. What do they mean by the gradient?
Slope.
Slope, which is also known as the derivative. Well, how do we call the derivative? dy dx. So what they actually gave me for October, November 2002 is they actually gave me dy dx without telling me dy dx is. So the gradient is the square root of 1 plus 2x. The
What
curve
number is
has, say it again,
What number?
October, November, 2002, number 4.
Okay.
So it literally says the gradient is that, so I know dy dx is that, yes. Oh, yeah, that'd be great. So, and you're passing through 411. I would love that. Find the equation of the curve. You got this, good job. Thanks for asking me that. I love it. Oh, he has jelly all over the place. Oh, children. Gotta love them. No?
I get it, but it doesn't make sense.
First thing you would rewrite it, right, to the 1/2,
Yeah.
and you moved your dx over, and then you named u, and you took the derivative of u.
Yeah. And I brought the 1/2 to the outside.
Good job.
Then I have 1/2 times u to the 1/2 over 1/2, which when you multiply 1/2,
Wait, you don't need over 1/2.
why? When you do the integral,
There should be 3.
3 over 3 halves.
it'd be negative 3/2, which is 1/2.
Wait, to the 1/2.
Because when you bring
I
that
got it,
over,
got it. Okay, when you bring the 2 up, I got it. Okay.
so then it's like 1/2 times u over 1/2 to the 1/2, and then you get when you cancel out 2 of the halves, you get 1. So then you have u to the 1/2, and then u is just 1 plus 2x to the 1/2.
And where's your plus c?
Plus C.
Would you get us the answer? And you would get us my answer.
Nice try.
Did you get it? No?
No, well, I mean, yeah, I'm just,
Did
still
you get
with
your u?
yes.
That's half the battle. And you were able to rewrite it? It's so cute. The integral, right? Are we good?
Right.
So I have the integral of this would be y. And if I'm rewriting this, I have 1/2 the integral of u to the 1/2 and then du. Does that look like it?
Tell me over 1/2. U to the 1/2 over 1/2, because when you change that from square root, isn't it negative 1/2?
That's only if it's in a fraction.
It's already written up top. It's not down below. That's a good catch though, because the one we did earlier was down below, right? It was down here. Do you see it?
Yeah.
Okay. Has everybody caught up to me where I'm at? Am I good? Yeah? Yeah? Okay, good. Yes.
Do you have like a list of steps to go with? Because sometimes I'm having trouble which one you do
We
when.
could do that.
Yeah.
Let's finish this one and we'll do
Okay.
one with step. Okay, well, maybe not. So we'll figure that out. So we have 1/2, and then if I integrate, I got u to the 3/2 over 3/2 plus c.
And the du goes away.
The du goes away. So now, clean her up a little bit. If I take the 3/2 and swing it up, I got that, right?
Yeah.
What was u? U was 1 plus 2x to the 3/2 plus c. Do you guys agree this is 1/3? So if I plug in the 4 and the 11, I got 11 equals 1/3 times 1 plus 2 times 4 to the 3/2 plus c. So this is 9 to the 3/2, right? 9 to the 3/2 is the square root of 9 is
27.
3 to the third, 27. Plus c. That's nice.
9.
Subtract 9. 2
2,
is c.
3. Then put the 2 up there.
So it'd be, to make it pretty, it would be y equals 1/3, 1 plus 2x to the 3/2 plus 2. got
get
it?
that far, but I've been getting the other.
You get this stuff more. That's crazy, isn't it?
I thought I was shorter.
You have a shorter
without
way.
all of this stuff right, is that okay?
We gotta show you work.
Yeah,
How
I
many
have.
questions we
Okay,
have?
as long as you show your work.
You
What's
said
that?
this is Monday, right? Or-
Tuesday. I'll do it Tuesday. Because I won't be here, Friday? Yeah.
Will there be any problems on U-Substitution?
I might put one on there.
Will it be like one that's, easier to work
They're all
with?
pretty similar to this. They're not gonna do anything extreme. Not at this level.
Because this is already hard, but it's not like the easy problem with a hard concept, but not a hard problem with a hard concept.
it.
Yeah.